All right, let's take another look at factoring. So remember, so far, we've seen that if you have 4 terms, we're going to factor by grouping, which is also what we're going to be using today when we factor some more trinomials. If you have 3 terms, so a trinomial, we saw the case in 6.2 where if you just have x squared plus bx plus c, so where this leading coefficient is 1, don't usually see it written there, then all you have to do is use the big X. And so remember, this means we're going to multiply to this last number c, and we're going to add up to b and find those 2 numbers, whatever they are. And then you can go straight to the 2 sets of parentheses. In this other case, where we have a number in front of the x squared that is not 1, so ax squared plus bx plus c, and so this leading coefficient just means the number in front of the x squared is not equal to 1, then what we're going to have to do is we're still going to use the big X, but this time what we have to multiply to is going to be the product of A and C. So we're going to multiply that first number and the last number, and that's what we're going to be, it's multiplication. This is what we're going to multiply to, but we're still just going to be adding to B. And so then we're going to find our 2 numbers, and what we're going to have to do here is something called splitting the middle term. So let's go ahead and look at an example. Let's go ahead and factor 2x squared plus 7x plus 6. So now what I'm going to do is I'm going to set up our big X, and so what we have to multiply to is 2 times 6, so we're going to multiply to 12, and we're going to add up to this middle number still, 7. So if we go through all the factors of 12, we have 1 and 12, 2 and 6, 3 and 4, and so the pair that adds up to 7 is 3 and 4. And then what we're going to go ahead and do is we're going to split the middle term. So I'm going to draw in these arrows here. We're going to keep the first term, keep the last term. So we're still going to have a 2x squared plus, because both our numbers over here are positive, we're taking the 7x and we're splitting it up into 3x plus 4x. Keep the 6. And so you should always be able to go from this new polynomial here back to what we started with. Just by adding that 3x and 4x, you should get 7x still. That's a good way to always double check. A lot of the times, people might forget to put the x's here. If we don't have the x's, we would just have 3 plus 4, which is 7, not 7x. Always double check that you have, or that you can get back to what you started with. And now, since we have 4 terms, we're going to go ahead and group, just like we've seen before. So group the first 2, leave the plus sign, group the last 2. And then we can go ahead and factor out from each group. So out of the first 2 terms here, we can take out an x. So our 2 is still there, got rid of an x, so we have 2x. Plus, get rid of the x, we're left with 3. Plus, out of these 2 terms, we can take out a 2. And so 4 divided by 2 is 2, keep the x. Plus 6 divided by 2 is 3. And now remember, you're looking to make sure that these guys match. Once they do, or if they do, if they don't, then we can't factor this. But since they match, we can go ahead and factor out that 2x plus 3. And so we've gotten rid of those, and we're left with x plus 2. And so remember, for these, your check, especially on exams, make sure you're checking your answers. We just want to go ahead and FOIL that out, and you should end up with what you started with. All right, so I'm gonna go ahead and just write down the steps for you. So we're gonna split the middle term. And then we're going to factor by grouping. All right, let's go ahead and try some more examples. And again, we're just told to factor, so we have to know what method we're going to be using. The last section we cover is going to be kind of a mix of all these different types of factoring put together, so we can kind of see how to figure out which method we need to use. All right, so number one, let's go ahead and try factoring 2z squared plus 5z plus 3. So another nice one like we just looked at, there's no greatest common factor to take out from all three of these terms, and they're all positive, so it's going to give us some nice numbers to work with. So we want to multiply to 2 times 3, so we're multiplying to 6, adding up to 5. I'm not going to list out all the factors for all these numbers, but if we were to go ahead and list them out, the two numbers we get that add up to, oh, my pen's running out. There we go. That add up to, or sorry, multiply to 6, add up to 5 are going to be 2 and 3. So let's split that middle term, keep the 2z squared, split that 5z into 2z and 3z. Doesn't matter what order you put these in. Sometimes one is going to be a little bit easier. We'll see some where one's positive, one's negative. And I'll usually put the negative one first, just to avoid having to factor out a negative. But these ones don't really matter. It's going to factor either way. And now let's go ahead and group the first two terms, leave the plus sign, last two terms. And now let's factor out from each. So this first group here, we can take out a 2 and a z. So our first term, get rid of the 2 and one of the z's, we're left with a z. Plus, remember you still need to have two terms here because we're factoring out of a binomial. 2z divided by 2z is going to be 1. So make sure you don't just kind of lose that term because we got rid of the 2 and the z. We're still technically dividing. Plus, take out a 3 from both of those. First term is just left with a z. Plus, 3 divided by 3 is 1. Again, don't lose that term. And now let's factor out the z plus 1. And get rid of those. We're left with 2z plus 3. And again, just as a reminder, it doesn't matter which order these factors go in. So if you put 2z plus 3 times z plus 1, so if you flipped these around, that's perfectly fine. All right, let's try another one. Let's go ahead and try one with some negatives. So this next one, we're given 5p squared minus 2p minus 3. All right, so what we're going to do here is we're going to, again, use our big X. We're multiplying to the product of 5 and negative 3. Be careful you don't lose those negatives. So 5 times negative 3 is negative 15. Adding up to a negative 2. So since we're multiplying to a negative, we know we need a positive number and a negative number. And that means because we're multiplying to a negative with a positive and negative number, the difference of those has to be 2. The only numbers that multiply to 15 besides 1 and 15 are 5. Oh, I'm going to have to switch this around. Are going to be 5 and 3, and then we need to figure out which one's negative. Has to be the 5 to get a negative 2. So now let's split the middle term. I'm going to go ahead and do this one the nicer way. So what I mean by that is put the negative number first when you split the middle term, That way we can avoid having to factor out a negative in that second group, because remember, if we start with a negative, we have to factor out a negative. So I'm going to go ahead and put 5p squared minus 5p, so minus because it's negative, plus 3p minus 3. Let's group first two terms, last two terms. And then out of this first group here, we can take out a 5 and a p. So we're left with p minus, again, be careful, 5p divided by 5p is 1, plus, factor out a 3 from this group. So first term left with a p minus 3 divided by 3 is 1. And now finally, if we go ahead and factor out this p minus 1, we're left with 5p plus 3. And this method is something you can use on the other trinomials we were looking at where there isn't a number in front of that first term. This is totally going to work. It's just a longer way. So if you remember that shortcut that we talked about last time, definitely use that. This is going to take a little bit longer. But this works for all trinomials, so all polynomials with 3 terms. Okay, let's go ahead and try, let's go ahead and do 4x squared minus 2x minus 30. All right, so actually let me go ahead and switch this up. There is one on your homework where what they've done is they've written it in a different order. So they've given you something like this, let's go negative 30 minus 2x plus 4x squared. So now if they give you something like this, we have a trinomial, but if you notice the x squared isn't first. So what I'm going to do is I'm going to go ahead and rewrite this so that it's in standard form. So we're going to put 4x squared first, followed by the x, so minus 2x, and then minus 30. So if it's not in standard form, make sure you go ahead and rewrite it first. Now we can do our big X. Before we get to our big X, actually, let's go ahead and take a look at these 3 terms. Now, one thing to notice here is that they're all divisible by 2. We could factor a 2 out from all of these. And you do want to do that before you get to splitting the middle term, because if you don't do it here, for one thing, your numbers that you're working with are going to be bigger. 4 times negative 30 would be negative 120, which is pretty big, and we don't want to work with numbers that big. Having to go through all the factors is going to be a little bit tedious. And then if you don't factor out the greatest common factor here, you'll have to do it at the very end, and a lot of the time it's really easy to forget to do it. So let's go ahead and factor out the GCF now. And remember that you have to leave it in the front. So I'm going to factor out a 2. So we're left with a 2x squared minus x minus 15, dividing all of those by 2. And now if we do the big X, make sure that you multiply the first and the last term, and don't pay attention to this 2 in the front for the big X. That's just kind of hanging out in front, and I'm going to actually leave it off for a little bit of the factoring, but remember to bring it back in, just so it's not there kind of throwing us off. So let's go ahead and multiply the first and the last terms here. So that multiplies to negative 30, adding up to a negative 1. We go through all of our factors, we need a positive and a negative. That's going to be 6 and 5 that have a difference of 1. The 6 has to be negative. And so now what I'm going to do is I'm going to split the middle term, but I'm going to just go ahead and arrow this 2 down. And the reason for that is if we leave that 2 in the front, these extra parentheses we have here are going to get kind of in the way, and it gets a little bit confusing. So I just kind of like to leave it off, but make sure you arrow it down and write it down here so that you don't forget to bring it back at the end. Now I'm going to go ahead and just focus on this trinomial. So we're going to split the middle term. So we have a 2x squared. Again, I'm going to put the -1 first. So negative 6x plus 5x, and then minus 15. Now let's group the first two and the last two and factor out from each one. So we can take out 2x out of this first group. We're left with an x for the first term minus 3, got rid of the x, plus, let's take a 5 out from the second group. So we're left with an x minus 15 divided by 5 is 3. So they match. And now we're on that last step. So we've brought the 2 back. So I'm going to set up our parentheses here because we know it's 2 sets of parentheses. We can factor out this x minus 3, and we're left with 2x plus 5. When you're going through, if you're looking at any videos on my math lab, they might keep the 2 in the front the entire time. If you like it that way, you can go ahead and do it. I just don't like it because it kind of messes things up when you have a 2 just kind of sitting out in front here. In front of all these, you have to put extra parentheses or brackets around that group the entire time, and I just think it looks kind of messy. So I like to do this and just bring it back. All right, let's go ahead and try just a couple more here. This one is definitely a weird one. So this one we're given 15k squared minus km minus 2m squared. So this is another one that's kind of weird. Just because we have 2 variables, we don't usually see these, but it is a trinomial. And it's in standard form because we have our k squared first. We could technically put this m squared first, but the way they've given it to us is nice enough already. Let's check for a GCF first. We can't take out any numbers. They don't all have a k and an m, so we can't take out any of those. So now to our big X. We're going to multiply to 15 times -2, so -30. And we're going to add up to a -1, so same numbers as last time, but it's a different setup. So let's go ahead and put -6 and 5. And now let's split the middle term. Keep that 15k squared in the front. And now it looks more complicated than the other ones we've done, but it's actually going to be just about the same. The only difference is when we split this middle term, instead of just having one variable, we have a km. So I'm going to put -6 km and plus 5 km. So if you notice, they're like terms. So if we added them together, we would get that -1 km. So we're still good. Still bring down that -2m squared at the end. And now the grouping is going to be really nice. We're going to group our first 2 terms, group the last 2 terms. And now if we factor out, we're just going to have some extra variables to factor out. Our GCF here is a 3 and a k, so 3k. We're left with 5k minus 6 divided by 3 is 2, left with an m, plus, now with this one we can't take out a number, but we can take out an m. So our first term is just left with a 5k, minus, we're left with a 2 and an m. So these guys match, so that's good. And we can go ahead and factor out that 5k minus 2m. And we're left with 3k plus m. So this one looked uglier because of those 2 variables. But just remember, if you have a trinomial, big X, split the middle term, and you just kind of follow through with that factor by grouping. All right, let's go ahead and try one more. So for this last one, number 5. Let's go ahead and factor 18 p to the 4th plus 63 p cubed plus 27 p squared. So now, first thing you should notice about this one is we don't start with a p squared, we start with a p to the 4th, and that's a really good indicator that you're going to have to factor out a greatest common factor first. And if you look at the numbers, they're a little bit bigger, and they're all divisible by 9. So let's go ahead and factor out the GCF first. You can take out a 9p squared. So we're left with a 2p squared plus 7p plus 3, and the p squared is gone. And now we need to factor this trinomial in the front. I'm going to go ahead and arrow this 9p squared down and bring it back in at the end, just so we don't have to deal with it. And then our big X, multiplying to, again, ignore this 9p squared in front. We're multiplying to 2 times 3, which is 6, adding up to 7. So a lot of times it's really easy to forget the 1 and 6, or that 1 is a factor of a number. Those are the factors we want here, though. We want 1 times 6 so that we can add up to 7. And let's split this middle term. So I'm going to leave this 2p squared in the front, and I'm going to actually put the 6 first and then the 1, just because I want to show you something specific here, but it doesn't matter, again, which order you put it in. The 1 is actually a little bit nicer to go first. But I want to show you this kind of more complicated way, just in case you end up writing this way down. So I'm going to put plus 6p plus 1p, or just p, plus 3, and then we'll group. So we can take out a 2p from here. So first term, we're left with a p, plus second term, we're left with just a 3, got rid of the p, plus, now this is why I wanted to show you this one, just so you don't forget that you can still factor something out here. So we don't have any numbers in common, no variables in common, so our greatest common factor is a 1. Make sure you don't forget that to write that down, because we are going to need that 1 in our final answer. But if we divide by 1, it doesn't change it. P divided by 1 is still p. 3 divided by 1 is still 3, which is what we want because now we have matching p plus 3s. And now I'll bring this back down here for a final step. Factor out that p plus 3, and we're left with 2p plus 1. And that is factoring trinomials by grouping. So those are just the 2 different techniques we've seen for trinomials. So we've seen 4 terms, which is grouping, taking out the greatest common factor first, and then these 2 methods for trinomials depending on whether or not that first term has a number in front or not. So remember, no number in front, you can use that shortcut, which makes it a lot faster. Or this kind of fallback method where you split the middle term. You have to use it when you have a number in front of that first term. If not, it can still be used, it's just a little bit longer. All right, so the next time we're going to be looking at something called special factoring techniques. We're skipping over 6.4, so you don't have to look at that one at all. And then 6.6, we're going to take a look at just kind of a general approach to factoring. So we're going to go through all the stuff we've seen so far, and then take a look at some kind of mixed examples to know when to use what factoring technique. And then our last section we're going to take a look at is solving equations using factoring.